That's not everything. In this video, I'm going to explain the MLT experiment number 8, implementation of self-organizing map clustering. First, I installed the required library called MLT using PIC. This library helps me implement the self-organizing map algorithm. And then I imported the all necessary libraries, pandas and numpy for handling data, matplotlib for visualization, standard scalar for scaling the data, Celotti score for evaluating the clustering, and winsum for self-organizing map clustering. And then I loaded the data set. What I did is I loaded my data set by fcm.csv using pandas. I displayed the first few rows using head and also checked the shape of the data set to understand its size. And then handled the missing values. After loading the data set, I checked for missing values. I handled them by replacing missing values with the mean of each column using fill now. This ensures the data set is clean. And then standardizing the data. Next, I standardize the data using standard scalar. This step converts all values into the same scale, which improves clustering performance. And then setting self-organizing map parameters. What I did is, I defined the parameters for the self-organizing map algorithm. Learning rate is equal to 0.5, sigma is equal to 1, controls neighborhood influence, iterations is equal to 100. These parameters control how the self-organizing map learns from the data. And then visualizing data using scatter plot. I created a scatter plot using the first two features of the data set. This helps me visually understand how the data points are distributed. And then applying self-organizing map for different clusters. What I did is I applied the self-organizing map algorithm for different cluster sizes from 2 to 5. For each cluster value, I initialized the self-organizing map grid, randomly initialized weights, trained the self-organizing map using the data set, found the winning neuron for each data point, assigned cluster labels. Then I calculated the Celotti score to evaluate clustering quality. And then plotting Celotti score. What I did is I plotted a graph between number of clusters and Celotti score. This helps me visually identify which cluster size performs best. And then selecting best cluster. What I did is I selected the best number of clusters by finding the maximum Celotti score using numpy argmax. And then training the final self-organizing map model. What I did is using the best cluster value, I trained the final self-organizing model again with the same parameters. And then displaying the cluster centroids. What I did is I extracted the cluster centroids using get weights and printed them. These represents the center of each cluster in the self-organizing map grid. And then visualizing final clusters. What I did is I assigned the cluster labels to all data points and plotted them using a scatter plot. Each point is colored based on its cluster, making grouping clearly visible. And then exporting the result. Finally, I added the cluster labels as a new column in the dataset. Then I exported the dataset as a CSV file named SOM output.csv for further analysis in tools like Power BI. Thus, I successfully implemented self-organizing map clustering, evaluated the best number of clusters using CLOT score, visualized the clusters, and exported the results. That's all. Thank you.